Nikola Tesla, the visionary inventor. New York City, 1898. The air inside Madison Square Garden is thick with the smell of ozone and nervous anticipation. A crowd of spectators gathers around a large tank of water. On the surface, a small, sleek boat sits motionless. There is no visible tether. There are no wires connecting the vessel to a pilot. Then, something happens. The boat jerks forward. It turns. It navigates the water with a precision that seems impossible for the era. Tesla stands nearby, calm and composed. He is not using a remote control as we understand it today, but a device that transmits wireless signals to manipulate the craft. The reaction from the onlookers is immediate. Many do not see a breakthrough in telecommunications. They see sorcery. To the audience, this is not merely a mechanical feat, it is a performance of magic. The line between rigorous science and the supernatural begins to blur in the minds of the public. Tesla has become more than an engineer. He is a man who can command matter through the invisible currents of the air. This spectacle raises a question that would haunt his legacy for decades. Was Tesla a wizard of a new age, a man who could see the future of the planet? Or was he a man fundamentally out of sync with the world he inhabited? He possessed a mind that could grasp the complexities of polyphase alternating current, yet he often struggled to exist within the rigid structures of 19th-century industry. His brilliance was a double-edged sword. We see the emergence of a profound duality. On one side, there is the visionary engineer. This is the man who would eventually help light the 1893 Chicago World's Fair with 160,000 lamps. He is the architect of the modern electrical grid. On the other side, there is the isolated eccentric. This is the man who would eventually retreat into a world of private obsessions and scientific theories that drifted far from the established physics of his peers. To understand the man, we must understand both the light and the shadow. The year is 1856. The setting is a small village within the military province of the Austro-Hungarian Empire. Here, amidst the rigid structures of a vast empire, a child is born into a world of strict order and emerging industrialism. This is the landscape that would shape a mind capable of seeing through the very veil of reality. Tesla's path led him away from the quietude of his birthplace and toward the intense intellectual rigor of Graz. At the Technical University, he immersed himself in the demanding disciplines of physics and engineering. The curriculum was heavy, mathematical, and precise. It provided the structural foundation for a man who would eventually dismantle the existing understanding of energy. During these formative years, a singular obsession began to take root. It was not merely the study of machines, but a fascination with the invisible forces that governed them. Electricity was not a mere subject of study, it was a mystery waiting to be decoded. While his peers focused on the mechanics of steam and gears, Tesla looked toward the currents that flowed unseen through the air and the wire. By the time he completed his studies, the internal spark had become a driving force. He possessed a mind that did not just observe the world, but sought to reconfigure it. His training in Graz gave him the tools, but his intuition gave him the vision. He was no longer just a student of engineering, he was becoming an architect of the future. The journey toward the new world began in earnest after a stint in Paris, where he worked for the Edison company. In June 1884, he stepped onto the docks of New York. He carried no vast wealth or established reputation. He had only his intellect, his notebooks, and a relentless drive to master the currents of a changing world. The War of the Currents. Before the skyscrapers of New York were lit by the hum of electricity, a battle raged in the shadows of the industrial age. It was a struggle for the very soul of the modern city. On one side stood Thomas Edison, the established titan of the era, championing direct current, or DC. His system was steady and safe for small distances, but it was limited. To light a city with DC, power stations had to be placed every few kilometers to prevent the voltage from dropping. On the other side was the rising force of alternating current, or AC, a system capable of being stepped up to high voltages and sent across vast distances. The conflict is often painted as a morality play. In this version, Edison is the unscrupulous capitalist, a man obsessed with protecting his patents at any cost, while Tesla is the free-thinking genius, a martyr for progress. This narrative simplifies a much more complex reality. Edison was a practical businessman building an empire, while Tesla was a brilliant engineer whose ideas were often ahead of the infrastructure required to support them. The battle was less about good versus evil and more about which technology would dictate the layout of the 20th century world. Tesla's journey to this industrial battlefield began in Europe. He arrived in New York in June 1884, carrying little more than a letter of recommendation to the Edison Company. Before reaching America, he had already made his mark in Paris, working with the most advanced electrical minds of the day. He was not merely a dreamer, he was a man who understood the mathematics of the machine. His arrival coincided with a moment when the world was hungry for light, but the method of delivering that light remained a matter of intense, often bitter, commercial dispute. The stakes were nothing less than the electrification of civilization. The winner would control the infrastructure of every home, factory, and street lamp on the planet. As the systems clashed, the race to generate power from the massive falls of Niagara became the ultimate prize. It was a contest that would eventually decide whether the future would be built on the steady, local pulse of DC, or the sweeping, high-voltage reach of AC. The polyphase breakthrough. By the late 1880s, the battle for the grid was stalled. Thomas Edison's direct current was safe, but it was limited. It could not travel more than a few kilometers without massive power loss. The industry needed a way to move electricity across vast distances. Tesla had the answer, but it required a fundamental shift in how we understood motion and magnetism. He focused on the rotating magnetic field, a concept that seemed almost impossible to his contemporaries. The secret lay in the polyphase system. By using multiple alternating currents, each slightly out of step with the others, Tesla could create a magnetic field that actually rotated within the motor's stator. This was the induction motor. It was elegant. It was efficient. Most importantly, it solved the greatest mechanical headache of the era, the commutator. In Edison's DC motors, brushes rubbed against a spinning commutator to switch current, causing constant friction, sparks, and rapid wear. Tesla's motor eliminated these moving parts entirely, using the magnetic field itself to pull the rotor around. In 1888, Tesla took his vision to the halls of academia. He demonstrated his system at Columbia University, proving that his alternating current could drive heavy machinery with unprecedented ease. The demonstration was a turning point. It was no longer just a theoretical curiosity. It was a functional reality that could power an entire city. But a patent is only as strong as the capital behind it. Tesla found his champion in George Westinghouse. Westinghouse was a man of industry with the resources to challenge the Edison monopoly. They formed a strategic alliance that would change the world. The partnership was not without its costs. To ensure the survival of the company and the success of the polyphase system, Tesla made a choice that would haunt his later years. He surrendered his royalty rights. He chose the triumph of the technology over his own personal wealth. This alliance provided the momentum for the ultimate victory. The polyphase system was no longer a battle of ideas, but a standard for the modern age. The Showman of Science. Chicago, 1893. The World's Fair is a sprawling landscape of white buildings and electric dreams. For years, the public has lived in fear of alternating current. Critics claimed the high voltage was a lethal threat to the household. Then, the sun sets over the Midway Plaisance. Suddenly, the darkness is shattered. Over 160,000 lights flicker to life simultaneously, transforming the fairground into a glowing metropolis. It is a triumph of engineering and a massive victory for the Westinghouse system. The spectacle does more than illuminate the fair. It proves to a skeptical world that alternating current is both safe and practical for the modern age. Tesla understood that science alone was not enough to win the battle for the grid. He became a master of the public demonstration. He did not just publish papers. He staged events that felt like magic. He would stand in a laboratory, surrounded by high-voltage coils, while currents passed through his own body to light lamps in his hands. These displays were calculated. They were designed to capture the press and secure the interest of investors. To change the world, Tesla knew he had to command the attention of the world. This instinct for the spectacular came at a staggering personal cost. In the heat of the competition, George Westinghouse faced a financial crisis. His company was on the brink of bankruptcy. To save his partner and ensure the AC system survived to power the planet, Tesla made a devastating choice. He signed away his royalties. He traded his future wealth for the survival of his technology. He was a man who prioritized the success of his vision over his own fortune. The decision secured the future of the electrical age, but it left Tesla's own finances in a precarious state. He had helped build the foundation of the modern world, yet he would spend much of his life struggling to fund his next great leap. The showman had won the war, but the cost was his stability. By the turn of the century, Tesla's focus had shifted from the wires of the city to the very medium of the planet itself. He envisioned a world where electricity was not merely piped through copper cables, but pulsed through the earth as a vast, resonant conductor. His laboratory at Wardenclyffe on Long Island was to be the heart of this system. He planned to use massive towers to transmit power through the ground and the atmosphere, allowing anyone, anywhere, to tap into the energy without a single wire. The scale of the ambition was immense. The tower was to be a colossal structure, designed to shake the very crust of the Earth with electrical vibrations. To Tesla, the planet was a giant capacitor, a vessel capable of carrying energy across oceans. This was not simply a new way to send a telegraph signal. It was a fundamental redesign of how humanity would interact with energy. He sought to provide power to the most remote corners of the globe, free from the constraints of traditional infrastructure. But grand visions require capital, and the financial world was far less certain than Tesla's electrical theories. His primary patron, J.P. Morgan, had invested in the wireless telegraphy aspect of the project, but the prospect of wireless power was a hard sell for an industrialist. If electricity could be pulled from the air for free, the established models of utility companies and metering would vanish. As the costs of the Wardenclyffe construction mounted, the money dried up. The dream was no longer just a technical challenge, it was a financial impossibility in a world governed by profit margins. This lack of funding marked a turning point. Tesla's scientific path began to drift away from the consensus of the physics community. While the scientific establishment moved toward a precise understanding of electromagnetic radiation and radio waves, Tesla's theories grew increasingly unconventional. He began to challenge the very foundations of how light and matter interacted, moving into a realm that many of his peers dismissed as mere eccentricity. The gap between the man who had lit the Chicago World's Fair and the man in the Long Island laboratory grew wider with every passing year. The tension was palpable. On one side stood the rigid, practical demands of industrial capitalism, requiring efficiency, patentable products, and predictable returns. On the other stood Tesla, a man driven by a singular, idealistic vision of universal access to energy. He was a disruptor who refused to play by the rules of the market. In his pursuit of a wireless future, he found himself increasingly isolated from the very world he had helped to electrify. By 1943, the man who once illuminated the World's Fair lived in a state of profound isolation. The electrical currents that had once pulsed through his veins and the cities of America had slowed to a trickle of meager pension payments and small hotel bills. He spent his final years in a single room at the New Yorker Hotel, a ghost of the high-stakes industrialist he had been. The grand laboratory at Wardenclyffe was a distant, fractured memory, replaced by the quiet, repetitive rhythms of a man living on the edge of poverty. As the decades passed, Tesla's scientific focus drifted away from the consensus of the laboratory and toward the edges of the known universe. He began to challenge the very foundations of emerging physics. Most notably, he denied that radio waves were electromagnetic radiation, a stance that placed him in direct conflict with the scientific orthodoxy of the 20th century. While the world moved toward a standard understanding of wave theory, Tesla remained tethered to his own private, often eccentric, visions of how energy moved through the ether. The myth of the martyr. Historians often find themselves caught in a debate over his legacy. One narrative paints him as a martyr, a genius crushed by the weight of predatory capitalism and the cunning of men like Edison. It is a compelling story of the visionary versus the financier. However, a more pragmatic view suggests a different reality. Many scholars argue that Tesla was a brilliant engineer who made catastrophic business decisions. By surrendering his lucrative royalties to ensure George Westinghouse did not face bankruptcy, Tesla prioritized the survival of the alternating current system over his own immense wealth. This tension defines the man. Tesla was the ultimate disruptor, a figure whose intellect operated on a scale that the financial and institutional structures of the 19th and 20th centuries could not support. He did not just want to improve the world, he sought to rewire it entirely. Whether he was a victim of circumstance or a man who simply refused to play by the rules of commerce, his impact remains undeniable. He was a prophet of a future that the world was not yet ready to inhabit.